Okay, we're in Math 121, Project L. Again, assumption, you're quite capable of creating a Jupyter notebook, and you're quite capable of running this from the terminal as well. I actually prefer to use the terminal, but again, if I were sharing this with somebody, I probably would not even use Jupyter. I'd probably use LaTeX and SageTech combined together to share the information. But that's not typical. Most people who are going to share information are going to share it with a Jupyter notebook. At least I would believe that would be the case. This one over here is a project using Sage. It's a piecewise defined function. Piecewise defined functions were introduced in Math 119 and certainly reinforced later on when you did other piecewise functions, including in this course here, Math 121. But, I want to point out, I would certainly, I want to look at this over here. It says use Sage to graph the piecewise defined function. Once graph is completed, you should use Sage to see if the derivative is defined there. All right. So what I want to do is, it's more difficult, but again, there's some issues with this as well. But I want to go back and I want to use Sage. And let me just clear this out, this old data there. And I'm going to start typing things in. So reset. I'm going to make x a variable. X is a variable. And then I'm going to start copy pasting, all right? So I'm going to copy this thing here. Got that done. I'm going to copy this thing over here. All right, so I want to tell you what I've done, and I've done these two functions over here, sine 1 over x. I see that right here. And the other part of that function, the second piece of it, is going to be, let's see what's it going to be. It's going to be x minus 2 over pi squared plus 1. And now I'm going to do this piecewise business over here. Again, I want to warn you against copy paste. If you do something like this, you're going to have trouble because I'm copying that line number there, and I don't want to do that. So I'm going to do this here. Don't be discouraged, and be encouraged that you can actually try. And then I'm gonna copy paste the second thing. All right, this thing over here. And I'm gonna hit return now. Now, by the way, someone can say, what's Sage doing now? And I often wonder what Sage is doing now as well. I'm gonna run my top command. And top is gonna give me a display of what's going on over here. And you notice that Python is taking up 102% of my CPU. Now, by the way, I have multiple CPUs running. If you notice that the computer, 75% of it's idle, but one of the processors is really saturated beyond belief, right? About 105, 102%. Now, my personal gut feeling about this over here is that Sage is, I don't know enough about Sage to understand why that's happening, but I probably did something really bad in the coding of this for Sage to be doing that. But I got to be honest with you, Sage is working hard on it. I don't know why it's having trouble with it. My suspicion is it's this problem over here, which is the sine 1 over x. And what's happening over there, it's horribly hyperactive when you get close to 0. I mean, there's a tremendous amount of activity when the numbers are getting small. And I think what Sage is doing, I just finished, what Sage is doing is actually computing a tremendous number of points to figure it out. It just can't do it, by the way. I mean, it just oscillates so quickly, it's crazy, all right? But it drew the picture. It got that. I got that part done. So I'm glad it finished it out. But, so it took a few seconds to do it. But, like, my machine didn't get sluggish. It just took one of the processors over. It really did. It oversaturated the processor with the problem, which is good, though. See the efficiency of the processor. They're actually able to do the work, all right? So I got my graph there. Now, of course, what I want to do is I want to copy these, but then talk about it. All right, let me go to my back to my terminal. I'm going to quit this out, my top function, and I'm going to exit out of this. I'm going to go back to Sage. Give me 1 second to do so, and I'm going to clear, and I'm going to do this over here. Well, let's see what happened over here. Copy paste problem. Now, somebody's, I don't even know how you know it's copy paste. I'm reading it, invalid characters. I know it's a copy paste problem. It's this thing over here. I know it might seem like subtlety, but it's a problem. All right. Let me do the next one, and I want to put out the next one. I'm not going to copy paste, but I'm going to do the next one, which is minus. Now, instead of typing in plus, what I'm going to do is type in a minus sign. Right? I'm sorry, but I'm not going to type in minus. I'm going to put in the minus sign over there. And it's also, what does it mean? It means that pi over 2, there is that these functions are going towards the same value. All right, they're going towards the same value, which is 1, which is good news. All right, that's good news. And then I'm going to say, h is another variable. H is a var. No, I didn't copy paste that. I just typed it in. And I'm going to put, I'm going to type this in with a copy paste. Before I do it, though, I want to point out, I hope you realize these things are being copied. These are not, the symbol I want. But let's do this over here. Remember, I got to change something. I'll do that now. Single quote mark. I'm going to use the plus sign, this. Hit return. Again, we would expect that you'd read the code there. I'm going to do the same thing, but minus sign now. All right, getting a 0 again. All right. So what are you doing over there? I'm basically doing a difference quotient, which is that defining feature of the definition of the derivative. So I'm feeling pretty good at the 0, which means it's a horizontal tangent there. All right, so it's pretty much done. It says the derivative exists at this point and has a slope of 0. It's a horizontal tangent line at the point, and it certainly looks that way when you graph it too. Let me go back over that for you. In the graph of it, what are we doing? We're over here somewhere, and there is a horizontal tangent over there. Now, granted, if you want, you can, certainly zoom into that area over there. But you zooming into a graph, I'd say it's somewhat productive, but you're really not going to see the level of detail unless you understand the mathematics behind it. It is so important you understand the mathematics behind this problem, all right? So I think that covers it out. And again, they give a nice picture over here. I'm using Sage Tech to do that picture. And let's take a look if there's anything else to say about that. No, we'll go to Project M next. Thank you so much for paying attention, though.